Today we're live coding a Netflix system design interview with 3 engineers who have actually failed these before. No textbook answers, no perfect solutions, just real engineering under pressure. I'm Sam, and this gets messy fast.
I bombed Netflix twice. First time I spent 45 minutes on the recommendation algorithm and completely forgot about video delivery. Second time I over-engineered a solution that couldn't handle a single concurrent user.
I made it to the final round but failed on capacity planning. Turns out saying, we'll just scale horizontally, without numbers is not an acceptable answer at Netflix.
I actually got hired at Netflix, but only after failing their system design 3 times. Each failure taught me something crucial about how they actually think about problems.
Perfect. Today's challenge: design Netflix's video streaming platform. Alex, you're our interviewer since you know their style. Riley and Jordan, your candidates. No mercy.
All right, you have 45 minutes to design Netflix. 230 million global subscribers, 15,000 titles, 1 billion hours watched daily. Go.
Okay, let me start with requirements gathering. What's our target latency for video start time?
Under 2 seconds globally. Next question.
What about concurrent users, peak traffic?
Figure it out. You have the subscriber numbers. Show me your reasoning.
230 million subscribers, maybe 30% concurrent during peak hours, so roughly 70 million concurrent streams.
Wait, that's way too high. Netflix has multiple users per account. Average 2.5 users per account, but not all watching simultaneously.
Good. Jordan's thinking about household dynamics. What else affects concurrent usage?
Time zones. Global service means different peak hours. US prime time doesn't align with India or Europe.
Right, so maybe 20 to 25 million truly concurrent streams globally, but regional spikes could be higher.
Reasonable. Now design the architecture. Start high level.
I'm thinking user management service, content catalog, recommendation engine, video streaming service, CDN for delivery.
Stop. You're listing services without understanding the data flow. What happens when I click play on Stranger Things?
Authentication first, then check subscription status. Load video metadata, find best CDN endpoint. Start adaptive bitrate streaming.
Better, but you missed something critical. What if I was watching episode 3 and now I want episode 4?
Oh, playback state, we need to track viewing progress, resume points, and, oh god, what if the user switches devices mid-episode?
Exactly. Cross-device continuity. How do you handle that at scale?
Centralized user state service. Every viewing event updates a database with current position, timestamp, device info.
What database? 25 million concurrent users, each sending viewing events every few seconds. That's calculate it.
25 million users, heartbeat every 10 seconds, 2.5 million writes per second minimum, plus reads when switching devices.
That's insane write load. My SQL would die instantly. We need something distributed. Cassandra, DynamoDB.
Good direction, but what's your partitioning strategy? How do you ensure I can read my viewing state from any device globally?
Partition by user ID. Hash the user ID across multiple shards.
What if a user has multiple profiles? Family account with 5 profiles, all watching different shows.
Shit, partition by profile ID then, not user ID. Each profile is an independent viewing entity.
Language, Jordan, but yes, profile-based partitioning makes sense. Now, what about consistency? What happens if my phone updates viewing progress but my TV doesn't see it immediately?
That's eventual consistency should be okay. Like, if there's a few seconds delay in sync, it's not catastrophic.
Wrong. Think about user experience. I pause at 23:45 on my phone, switch to TV, and it starts from 20. How do I feel?
Frustrated as hell. Okay, so we need stronger consistency for viewing state. Maybe read your writes consistency.
How do you implement that with Cassandra across multiple data centers?
Write to all replicas synchronously, but that increases latency.
Latency versus consistency trade-off. What's more important, fast video start or accurate resume points?
Both are critical. Maybe. Async writes for performance, but sync reads from the most recent write location.
Interesting. How do you track the most recent write location in a distributed system?
Vector clocks, logical timestamps.
Too complex. Netflix actually does something simpler. Think about it, how do you order events from the same user across devices?
Client-side timestamps, but clocks can be skewed.
Exactly the problem. They use server-side timestamps with a sticky routing approach. All updates for a profile go to the same partition initially.
Oh, so profile hash determines the primary partition, and that partition acts as the source of truth for ordering.
Good, now let's talk video delivery. How do you stream a 4K movie to users globally?
CDN. Cache video files at edge locations close to users.
A 4K movie is 15 to 25 gigabytes. Do you cache the entire file at every edge server?
That's expensive storage-wise. Maybe segment the video, cache popular segments, stream less popular ones from origin.
What's a segment in video streaming?
Like chunks of the video file, 10-second segments that can be downloaded independently.
Close, they use adaptive bitrate streaming, multiple quality levels each segmented. How does the client choose which quality to download?
Based on bandwidth, monitor download speed and adjust quality dynamically.
What else affects quality selection besides bandwidth?
Device capabilities. A phone doesn't need 4K battery life on mobile devices.
Good, now the hard question, how do you handle a viral release? Squid Game launches and everyone wants to watch simultaneously.
Pre-cache the content. If we know it's a big release, push it to all edge servers before launch.
How much storage does that require globally?
Squid Game has 9 episodes, each may be 20 gigabytes in 4K. That's 180 gigabytes per edge server. If Netflix has 1,000 edge servers globally.
180 terabytes just for one show, that's expensive. Maybe selective pre-caching based on predicted regional demand.
How do you predict regional demand for a new show?
Similar shows' performance, genre preferences by region, social media buzz analysis.
What if your prediction is wrong? Seoul edge servers are overloaded, but Mumbai servers are idle.
Dynamic rebalancing. Detect hotspots and redirect traffic to nearby servers with capacity.
Latency impact of redirecting Seoul users to Tokyo servers.
Maybe 50 to 100 milliseconds extra latency. That's better than failed requests or buffer stalls.
Acceptable trade-off. Now let's talk encoding. How do you prepare Squid Game for streaming?
Encode it into multiple bitrates and resolutions. 4K, 1080p, 720p, 480p.
Netflix actually encodes 200 plus variants per title. Different codecs, bitrates, resolutions. Why so many?
Device compatibility. Older TVs might not support newer codecs. Mobile devices need different optimizations than TVs.
Plus content adaptive encoding. Action scenes need higher bitrates than dialogue scenes. How long does encoding 200 variants take?
Hours, days, if each episode is an hour long and you need 200 variants.
12 to 24 hours per episode using Netflix's encoding farm. How do you parallelize this?
Encode different variants simultaneously on different machines. Split each variant into chunks and encode in parallel.
Both. Now what happens when encoding fails halfway through?
Restart from the beginning, that's wasteful. Maybe checkpoint progress and resume from last successful chunk.
Good, what about quality validation? How do you ensure the encoded video looks good?
Automated quality metrics. Compare against the original source, measure compression artifacts.
Netflix uses VMAF Video Multimethod Assessment Fusion, but automated metrics aren't perfect. What else?
Human review, sample frames from each variant and have quality teams validate them.
Expensive and slow, Netflix actually crowdsources some quality checks. Let's move to recommendations. How do you suggest what to watch?
Collaborative filtering. Users who liked show A also liked show B.
Basic approach. What's the cold start problem?
New users have no viewing history, so collaborative filtering fails. New shows have no viewer data.
How do you solve new user cold start?
Ask them to rate some popular movies during onboarding, or show trending content based on geography.
Netflix removed star ratings years ago. Why?
People are bad at rating. They'd give critically acclaimed movies high ratings but not actually watch them.
Exactly, they switched to thumbs up down because it better predicts actual viewing behavior. What implicit signals can you use?
Watch time, completion rate, skip behavior, time of day viewing device used.
Good, if someone watches 90% of a movie but gives it thumbs down, what does that tell you?
They probably enjoyed it but didn't want to admit it, or maybe they hated the ending but were invested enough to finish.
Netflix weighs implicit signals more than explicit ratings. Watching is stronger than rating. How do you handle seasonal preferences?
Horror movies around Halloween. Christmas movies in December. Weight recent viewing history more heavily.
What about daily patterns? Do people watch different content at 2 p.m. versus 10 p.m.?
Probably daytime might be lighter content, kids shows. Evening could be more serious dramas or action movies.
Good insight. How do you A/B test recommendation algorithms?
Split users into groups. Show different recommendations to each group. Measure engagement metrics.
What metrics matter for recommendations?
Click-through rate on recommendations, total watch time, user retention.
All good, but what's the biggest challenge with A/B testing recommendations?
Long feedback loops. It might take weeks to see if a recommendation algorithm affects retention.
Exactly. Netflix runs tests for months to measure long-term impact. Quick question, how do you prevent one user's viewing from affecting another user's recommendations?
Isolation between test groups. Make sure users in Group A never influence the algorithm for Group B.
Harder than it sounds with collaborative filtering. If user A in test group 1 watches a new show, that affects recommendations for similar users in test group 2.
Oh shit, that's a data leakage problem. Maybe separate training datasets for each test group.
Language, but yes, very tricky to isolate properly. Let's talk about cost. How much does Netflix spend on AWS monthly?
Millions, tens of millions, with their scale and bandwidth requirements.
Around $15, 20 million monthly just for AWS. What's the biggest cost component?
Bandwidth. Streaming video to 230 million users consumes massive bandwidth.
Storage and compute are also huge. How do you optimize costs?
Smart caching strategies. Don't store unpopular content on expensive SSDs. Use cheaper storage tiers.
Good. What about compute costs for encoding?
Spot instances. Use cheaper, interruptible compute for batch encoding jobs.
Netflix pioneered chaos engineering. Why intentionally break your own system?
Find failures before customers do. Better to discover a weakness during controlled testing than during peak traffic.
Exactly. Chaos Monkey randomly terminates EC2 instances. What other failures should you simulate?
Network partitions, database failures, entire data center outages.
All good. Final question. A user complains that Netflix is slow tonight. How do you debug this?
Check their location, ISP, device type, current network congestion in their area.
What specific metrics do you look at?
Video start time, rebuffer ratio, average bitrate achieved, CDN cache hit rates for their region.
How do you correlate individual user experience with system-wide metrics?
User session tracking. Tag each playback session with user ID, device, location, then aggregate metrics by those dimensions.
Good. Time's up. Riley, you focus too much on perfect solutions and not enough on trade-offs. Jordan, solid systems thinking, but you need to be more decisive with architecture choices.
Brutal but fair. What just happened there? That's different from typical system design prep.
Real Netflix interviews drill into specific numbers, trade-offs, and failure scenarios. They don't want textbook architectures. They want evidence you can handle their actual problems.
I kept trying to give correct answers instead of reasoning through the problems. Real engineering is messier than that.
The questions kept evolving. Just when I thought I understood the problem, Alex would add complexity or ask about edge cases.
Let's break down the key moments where candidates typically fail. This episode was brought to you by Unstruct AI, creating the most trusted AI news analysis platform with a focus on the human cost. After all, progress without humanity isn't progress at all. We're back. Alex, you've seen hundreds of these interviews. What separates the candidates who get hired from those who don't?
Honestly, it's not about knowing Netflix's exact architecture. It's about reasoning under pressure and making trade-offs with incomplete information. Most candidates memorize solutions instead of learning to think.
That's what killed me the first time. I spent weeks memorizing CAP theorem and sharding strategies, but when they asked what happens when Sol's servers are overloaded, I froze.
The numbers game is brutal too. When Alex asked about 2.5 million writes per second, I had no intuition for whether that was reasonable or insane.
Exactly. Netflix engineers think in terms of concrete numbers, not abstract concepts. Scale horizontally means nothing. Add 50 more Cassandra nodes to handle 10 M write sec is useful.
Let's replay the moment where Riley almost lost it, the viewing state consistency problem.
God, that was painful. I said eventual consistency is fine without thinking about user experience. Who wants their show to restart from 20 minutes ago?
That's the trap. Candidates apply textbook distributed systems concepts without considering the human impact. Netflix's whole business is user experience.
And when you push back on my vector clock solution, I realized I was over-engineering. Simple server-side timestamps with sticky routing is elegant.
Netflix values simple solutions that work over complex solutions that might work. When you're serving 230 million users, complexity kills you.
What about the encoding pipeline discussion? That seemed to catch both candidates off guard.
I had no idea Netflix encodes 200+ variants per title. In my head, it was like, just make it 1080p and 4K. The reality is so much more complex.
Most candidates think video streaming is just serve files from CDN. They miss the massive infrastructure for content preparation, quality validation, cost optimization.
The economics shocked me too. $15, $20 million monthly on AWS alone. That changes how you think about every architectural decision.
Let's talk about the human elements that traditional system design prep misses completely.
Perfect example when I asked about A/B testing recommendations. Most candidates think it's just split users measure clicks. They miss the psychology.
Like people giving movies high ratings but not actually watching them, I never would have thought about that disconnect.
Or the seasonal preferences thing. Halloween horror movies, Christmas films. That's not in any system design textbook.
Netflix is fundamentally a psychology company that happens to use technology. Understanding human behavior is more important than knowing Kafka internals.
What about failure scenarios? The chaos engineering discussion seemed to reveal different thinking.
I never understood why you'd intentionally break your own system. But thinking about it now, better to find problems during controlled tests than during the Super Bowl.
Chaos engineering reveals a mindset difference. Most companies try to prevent all failures. Netflix assumes failures are inevitable and builds systems that handle them gracefully.
It's like the difference between building a house that never gets earthquakes versus building a house that survives earthquakes.
Let's get practical. For someone preparing for Netflix or similar companies, what should they focus on?
First, practice estimating real numbers. How many requests per second, how much storage, how much bandwidth? Get comfortable with back-of-envelope calculations.
And think about user experience first, technology second. Don't start with "I'll use microservices." Start with "users want fast video startup."
Learn about the specific domain. Video streaming has unique challenges: codec compatibility, bitrate adaptation, CDN strategies. Generic system design won't cut it.
Most importantly, practice explaining trade-offs. Every choice has costs. This approach gives us X benefit but costs Y and has Z risk. That's how real engineers think.
Any red flags that immediately disqualify candidates?
Saying no SQL is always better than SQL or microservices solve everything. Absolute statements show you don't understand trade-offs. Context matters for everything.
Or drawing boxes without explaining data flow. I did that, just drew recommendation service without thinking about how recommendations actually get computed and served.
Not asking clarifying questions is a killer too. Real requirements are always ambiguous. Good engineers ask the right questions to understand the actual problem.
What's the biggest misconception people have about these interviews?
That there's a correct answer. There isn't. We want to see your thought process, how you handle uncertainty, how you prioritize competing requirements.
I kept trying to impress with complex architectures, but simple solutions that work are way more impressive than elegant solutions that don't scale.
And they're not testing your knowledge of specific technologies. They want to know if you can reason about systems and make good engineering decisions.
Final question. What would you tell your past selves before that first Netflix interview?
Stop memorizing patterns and start understanding principles. Every system is unique. The goal is to think through problems, not recite solutions.
Focus on the user. Every technical decision should trace back to user experience or business value. Technology for its own sake is meaningless.
And be honest about what you don't know. Saying "I'm not sure, but here's how I'd investigate" is much better than bullshitting through an answer.
This has been eye-opening. We've seen how real Netflix interviews differ from textbook prep. It's about engineering judgment, not memorized architectures.
Thanks for the brutal but honest feedback, Alex. This felt more like real engineering than any practice session I've done.
Agreed. The human psychology aspects, the cost considerations, the failure scenarios, that's the stuff you only learn from actually working at scale.
Keep practicing, but focus on reasoning over memorization. The best engineers I work with are curious problem solvers, not walking architecture diagrams.
Until next time, remember that system design is about humans, not just systems. Technology serves people, not the other way around.
And if you're interviewing at Netflix, think like a user first, engineer second. That's what sets the great candidates apart.
Thanks everyone, time to go practice calculating write throughput for viewing state updates.
And I need to understand video encoding pipelines. Apparently, there's a lot more to streaming than I thought.
This has been Unstruct AI, where we strip away the artifice and show you how technology really works messy, human, and surprisingly fascinating.